Good morning, ladies and gentlemen. I hope you are all very well today. It is a beautiful day here in North Carolina, and today we are working more on our blockchain project. The goal for today is to implement a terminal interface and a data pipeline for our blockchain. So if you've seen some of the videos I've been releasing this week, I was showing how to create data pipelines, and if you were on my GitHub, you saw that I was putting out some challenges to demonstrate some terminal interfaces. And the reason for that was that today I want to implement those two things together to create a terminal interface for our blockchain. So let's take a look first at my GitHub profile, and I want to show you where you can see the source code for all of this. So libeom is a library of tools that we will be using, and we will probably be adding things to the project in a generic way through this library. And then we'll import this library into the blockchain project so that we can actually use the features in the particular way that we need for the project. Then there's the sketchbook, and this is just where I do experiments, and you can actually see a lot of the code that I was working on over the week to prepare for this in the sketchbook. So if you want kind of minute by minute things of what is going on in this code, the sketchbook is a good place to look for that. So I recommend going over to my GitHub profile and following me there if you want to see more of this code, and also joining our Discord server. The links for all of this are in the description. So let's jump into making our terminal interface and our command line, or our data pipeline, excuse me, not a command line pipeline. There are a few ways to go about doing this, and I think the best one is going to be to start with an example, and we're going to start with the terminal application here, and we'll kind of move into the data pipeline to that terminal. And we'll probably have to switch back and forth as we go. And there are also some decisions that we're going to have to make along the way that at this point in the project we might not be quite ready to make. So we'll note those and we will come back to them later. So let's take a look at an example here. So if I go over to my terminal and I move into the documents / this is my blockchain project. This is the project we're working on. And this is the Git repository that I am working on. And you can see that I actually have a few things in here that are not committed. And I'm going to go ahead and commit those things so I can push them out to GitHub for you. And also, it's going to demonstrate how we are going to interact with the program that we are making here. So the name of the application, or the binary executable here, is Git. So if I do ls/bin, or it might be /user/bin on Mac, we can see somewhere, there it is, Git. So Git, the command Git, is going to call that binary executable. And the final product for our project is going to be a binary executable like that. But when you type in a git command, you can follow it up with some arguments. So I can say git status, and it's going to print out this for me to tell me I have things that I need to commit. So then I can say git add, and then I can put in a third argument, a dot, and that's going to tell it to add everything. And then I can say git commit -m, and that tells it that I'm going to commit this change, but I'm also going to put a message on it. And then I can use quotes to type in a message. And we'll just say, we updated the project for the stream. And which branch are we on? We are on main. So I'm going to git push origin main. And you can kind of see how all of this is working now. I call the binary executable, and then I pass in a series of arguments that are interpreted by that binary executable into making it do something specific. Let me just finish this up here, and I will show you the actual source code for Git. And I actually have two remote repositories here, so I'm going to have to push it out to the public one as well. Okay. Excuse me. So let's take a look at the source code for Git. You can find the source code for Git on GitHub, actually, believe it or not. And I don't know if this is the official source code or what exactly is going on here. It was uploaded by Juanillo C. Hamano, and well, they live in Mountain View, California, so it could be that they are actually on, yeah, they're a member of Git. I don't know. So I don't know what this person's relationship is to the actual Git project. It may be, it may be more official than I'm making it out to be. And anyway, we get a good look at how the source code actually works. So if you want to see this, I will put a direct link to it. But on the Git page, I'll put this in the comments, actually, so that you guys all have access to the direct link. There we go. And in this repository, if we go down to a file called git.c, and then all the way at the bottom, we can see this function here, command main. And this is the function that runs when I am actually running it from the command line. So this is the main function when you are using a command line. And it takes 2 arguments. And actually what we would see is that if I create, I'm just going to do this here very quickly. I'll delete this file in a second. But if I create an empty C file, then you see it will automatically, oh, I guess it doesn't. Oh, it's because it's not the main file. So when you create a main file for a project, it will automatically put in the main function. Didn't do it here, so that was a terrible example. But generally speaking, the default arguments for your main function are int argc and constant character pointer argv. That is an array of pointers. And argc is going to be a number representing the number of arguments that you have, or the size of this array. And then this array, predictably, will point to each of those individual arguments. So we can see that, well, first of all, I want to point out that argc, as when you run the program, argc will be at a minimum 1. So argv, the very first element of that array, is going to be the name of the application. So here, if this was compiled into the binary executable Git, and I ran this, argc would be 1, and constant character would be, well, the first one in that array would be Git. So any arguments we pass after come after that. But what we can see is what basically goes on here is he checks if there is a command, and then he sets the command, and then he is basically separating out the different parts of it. So here we can see the problem here is it's done with a, well, it's not a problem, it's actually really great, but it's hard for me to explain because it's sort of hidden in these other functions here, and we can go through those functions, but we're kind of trying to focus on the big picture here. So basically what is going on is that the commands are split up into their components, and then we can create sort of a tree of possible results. And as we go through that tree, we can just look at one command, and that will bring us down to the next path. And then we can look at the next command, and that'll bring us down the next path. So we can create this branching structure where we can pass in all these commands and get the result we want. And this is just a good example of that done in practice. Now, there is something that this doesn't do that I want to implement for our blockchain, and I can demonstrate that with the programming language Python. So if I just type in Python 3, well, first, let me, oops. My fingers are going too quick today. I'm making a lot of typos. Let's excuse that. So with the programming language Python, I also have a command line interface for it. So I can just say Python 3. And before I actually execute that bare command, I want to show you a little bit more of what that can do. So I'm going to use another command, touch test.py. I'm going to write in it, print simple application. So I can use the command Python 3, and then the relative or absolute path of that file test.py, and it will take in this argument test.py, and it will run the code that is in there. So when I run that, it prints out hello world. But if I just type in Python 3 with no arguments, then I get this interactive shell where I can type in multiple commands. So I can say print hello world, print hello yourself. And we can see that I can just keep typing in Python commands. So essentially my terminal becomes a Python interpreter. And that will be really useful for our blockchain. So that is something that I want to add to our terminal that is not already present in this Git example. And we're going to need to be careful when we do that, because thinking ahead, as I mentioned at the beginning, we want to have data pipelines to this. So when using Git, we are typing in a command, and then we are executing it, and then we type in the next command, and then we execute it. And for the application that we are building, it's really designed to give just the base functionality of our blockchain. We just want to be able to create blocks, share blocks, store blocks, and query blocks. And for most applications, that's really not going to be enough. So what's going to happen is a third-party application will create a data pipeline in their application to this blockchain executable. And they will just pipe in the commands that they want to the executable to get those base functionalities. And then that third-party application can look at what is returned from that and filter it down further. So depending on your particular use case for any of this information, you will create this data pipeline so that you can get that base functionality and then expand on it in your use case. Okay? So the problem that we're going to have is that we need to detect when the user is activating this through a pipe or through a command line. So if I am activating it through a pipe, I cannot put data in and out the same way as I would through the command line. So in the command line, we have our standard input and output. I can just type commands in with the keyboard, and it will just print things out to the screen. It's pretty straightforward. But with a data pipeline, in the simplest case, it's a one-way street where the third-party application would be able to send a command to the blockchain application, but the blockchain application would not necessarily be able to send one back in the simplest use case. Again, I made a video on this earlier this week, and I will, in the future, put a little card to it, wherever that is relative to my body, and I will put a card in to link to that. But anyway, we'll have to create a more complicated data pipeline in order to get things going back and forth. And again, we'll have some design decisions to make there, but we'll cross that bridge when we get there. And the real point here is that if we are going to be sending data that way, then the way we would do it with an interactive shell actually won't work. So we need to, as our first command line argument, detect the way in which the user is interacting with the application, and then that will create our first branch of how this thing is actually going to expect the command to come. Okay? Now, that was a quite the intro. So the thing I want to do now is actually implement a generic terminal interface. And I want to do this in the generic because a terminal interface, as I've shown, is present in a lot of different applications. Python has one, Git has one, this blockchain project is going to have one. It seems reasonable enough to me to think that there may be another use case for this in the future. So we are going to start in libeom, and we are going to try and add a terminal interface. And to do this, I actually want to create a new section in the library. But before I do that, let's go to the terminal, and let's make sure my Git repository is ready to accept some new changes. Documents/libeom. Okay, and we are on the working branch. We have some changes in here. This is just Xcode storing some useless information. This is I deleted an old library file, that's fine, and I created a new library file. I'm not really worried about any of that, so as long as we are on working, great. Okay, we are ready to go. Now, I'm going to create a new section of the library just called user interfaces. And I'm considering a terminal interface to be a user interface. It certainly is, but I don't think that we often would consider it like that because it's so basic. But really, it's to me, actually, it's a very elegant user interface. It's highly efficient. So Xcode is great. Okay, I really like using Xcode, especially for its error messages and things like that. But there are some things I just don't do in Xcode. So Xcode has built-in source control. So I can commit, push, pull, do all these things, create new repositories. I can do all sorts of crazy stuff with Xcode. I don't. I go to the command line, I type in the arguments for get, I just do it manually. And the reason for that is that it's really easy to remember the phrase git commit -m, type in whatever I want. But with this user interface, source control commit, I just haven't used it. I don't know what's going to happen when I hit that button. I just find it a lot easier to work on the command line actually a lot of the time. So, not really sure why I was even saying that. Oh yeah, user interfaces. So, I'm going to create a section of user interfaces, and I think a terminal interface is inarguably in that section. So let's create a scan out of folder. Gotta click on that. Group. Let's just call it interfaces. And I want to keep them in alphabetical order. Okay. Create a file. Do I capitalize these? I think so. Okay, now what I'm envisioning for this has to do with the main function. So if we remember in the example code here from Git, we take int argc and constant character argv. And what argv, excuse me. So what I'm thinking is that if you import this library into the project and you want your application to have a terminal interface or a command line interface like this, then what you're going to do is basically your main function is just going to call a new function. And that function is going to just be the terminal function. It will then pass argc and argv into that function, as well as a third function, and that is going to be the interpreter. That's where you define all of the different paths your commands can take and what they do. So you will pass in the arguments and how those arguments are to be interpreted, and this generic interface is just going to separate out the different possibilities where the user has passed in a command and is using that interface, or is trying to activate a shell interface. Whichever one we need, that's what we're going to do. So we are just going to define a function in this. And this function it will return the same thing that your main function would return. That way we can basically just substitute them from one another. And we'll just call it terminal. I'm going to take int argc and argv, and then we are going to pass in a function pointer, and this is going to be the interpreter. And I actually am not quite sure what the return value for the interpreter should be. Void seems reasonable. It also seems reasonable to have it return the int, so we could pass the error, the success or failure of the command would happen within the interpreter. So it seems reasonable that the interpreter would want to return that numeric value for the program to return. So maybe we should have int pointer to a function called interpreter, and the interpreter is going to take int argc argv. So we're essentially just passing the command down the line, just kicking the can down the road to whoever is going to handle it next. So first we get into our main application, and main knows that this is going to be a terminal application, so we just throw it on down the line. The terminal will do a few things, but largely it is just going to determine how exactly we are going to interact with it. And whatever our interaction is, it's just going to pass that on to the user-defined interpreter, which will actually activate things. So let's see how this is actually going to work in practice for that to make sense. So I'm just going to copy the signature so we don't have to waste time retyping it. Okay. So the first thing we need to do is basically check the number of arguments. And this is really efficiently done with a switch statement. A switch statement, if you haven't seen it, is very similar to a if-then structure. But basically, it's just a simpler version of it. So we pass in our switch argument is going to be argc, and that is just going to be the number of arguments. And then each case is just a different possible value of argc. So if argc is 0, we are going to do this. If argc is 1, we are going to do whatever we do there. And then we have a default. Now, it's an efficient structure, but there are some things about it that make it a little weird to write. So after each case, as soon as one of these cases evaluates as true, everything after it is going to execute. So if the case is 0, if this evaluates to true, it will execute this, and then it will execute this, and then it will execute this. So after each case, we have to explicitly tell it to break if we don't want it to execute everything following. Seems a bit strange, but there it is. And our cases have to be a little bit simpler. So with an if-then statement, we can actually be a bit wild with our cases. We can pass in function calls. We can pass in anything we want, really. Our if-then can be quite complicated, whereas here, the only thing we can pass in as the case is the value of our switch, which is, in this case, just some integral value. So what are we going to do? Well, if there are no arguments, if argc is 0, something strange has occurred. So argc should be at least 1 all the time, the name of the binary executable. We are going to printf we'll just say not enough arguments, and it's probably better. Yeah, p error, that will be better. The difference there is basically where that message goes. So using printf, it's basically going to send the output to standard out. So print it to my screen. Whereas p error may be printed to my screen. So we can redirect these routes. So let's say I didn't want when my user was actually using it, every time there was an error, let's say I don't want it to actually just print out a bunch of error messages on the screen. I want it to just log those in a file for the user to view when they so choose. So we could redirect p error to whichever file we want. And if I just use printf, it is going to try and print things to the standard out. And I wouldn't have the ability to have a comprehensive redirection of all of the errors in the project with a single statement. I would have to go through and change every single one to write it to a particular file. So it's worth it to be careful with these. Also, it's not necessary for me to do this in this case, but I'm going to. I'm going to wrap these in brackets. And the reason for this, I will reveal in just a moment, is that it's just like a loop or an if statement where you can put the case and the immediate line after can be the one command for that case. But if you want multiple, you need these brackets. And since I am going to have multiple in some of them, I'm just going to put brackets on all of them for consistency, with the exception likely being the default, because there's nothing else to do there. Anyway, now, once we have this, we will probably break or return the error status. So we would want to return like 1 or 9 here. And I don't remember exactly what those error codes should be, so I'll probably take a look. Camel Trader, hello. P error also prints the error number. So fprintf standard error would be the thing you want to do. So you can also redirect standard error and standard out globally if you want to do that. Exactly. And that is really the benefit of using these things properly, is that you can have a lot of control over where these things go. And another thing is, this is very similar to our data pipelines, where using those, we can actually have a lot of control over where things go and how things work. So thank you for joining me, Camel Trader, and thank you for commenting. I appreciate it. And it's telling me something over here. The stream's current bitrate is 1658.3 kilobytes per second. Apparently that's lower than normal. So if you are seeing weird things in the stream, please let me know. I don't know what I can do about it, but I'd like to know what's going on your end. Anyway. All right, so we're going to print that, and here I could do a return 1 to have that error code. I'll need to look up what the actual number is. Camel Trader, if you know that actual number, I'd appreciate it. But instead of that, I am going to just create a variable called, what do we want to call it? Result. And we're going to set it equal to 0. And then here we can say result equals 1. And then we can return result at the end, and it'll just be a little bit more elegant. So the only reason I'm doing that is putting a return statement here and then a break. It's unnecessary to do. It's if we hit that return, it's going to return, and the rest of it will never execute anyway. So it's just a little bit strange to look at, versus here I kind of segregate the two functionalities, where the switch statement is only determining what the result of this is. It gathers that result, and then it just returns that result at the end. So we kind of keep those separate. Camel Trader, exit failure can be used to return errors from main. Find end standard lib.h. So I believe what you're saying is, if I equals, there we go. Great, thank you. What number does that actually line up to? And Brandon, your name's a bit small, so I may not have seen that right, but it's not required to put curly braces in the switch cases. No, it is not required. So in this, it's actually the same thing with a loop. So if let me just go down here, and so I can do a for loop. Just like that. And I need to put a little tab there. And you don't actually need the brackets. So it will, if you have a single line after it, it will execute that single line using that. But if you have multiple lines, that's when you need those brackets. And Xcode is kind of resisting me doing this. I think there's an example of it right here in the code for Git. And assuming that is in fact the source code that Linus Torvalds wrote, I am willing to trust him. Here's an example of it in an if statement. So we can see there are no curly brackets in this if statement, and that's because there's only one command after it. And that's the circumstance where you don't have to use the curly brackets. Here we have it again, and here's a for loop with brackets because it has multiple lines, but you get the picture. Anyone? Okay, Camel Trader. It's also a corresponding exit success, which is par standard equal to returning 0. That makes sense. And you need it if you want to declare variables, though. That makes sense too, because you would need multiple lines. And you know, I'm not sure if it's the case. So if I did my for loop here, I could create a new variable x equals I. And if that's the only command, I actually not sure that that is correct, Camel Trader. If that's the only command, nope. No, it doesn't like that. You are correct. I stand corrected. Thank you. I've learned something from you. Did not like that. Interesting. So you cannot declare variables. I wonder why that is. Anyway, Okay, so we've gotten sidetracked here, and I need to excuse me for that. I use my iPhone as the face cam here, so once in a while I get notifications. I turn on Do Not Disturb, but apparently my Apple Watch charging to full is worth your guys' attention. So there you go. Camel Trader, fun fact: you also don't need to brackets after switch. Switch are do you mean this bracket or this bracket? The one under switch or the one under case? And also, is that only true if there's only one case? So yeah, interesting. Okay, so assuming we have one argument, then we want to determine whether that one argument, so if we have a single argument, then there are two possible scenarios. The single argument case is either where I am activating it from a data pipeline and it should expect commands to come from that pipe, or it is going to be the user actually typing things into the interface and they should expect command line arguments. And the problem is that those things happen in different ways. So if I am waiting for the user's input in a shell interface, then I'm waiting for them to type something and hit enter. Now, in the case of these pipes, I'm waiting for something to be written to the pipe. And the actual mechanisms of that happening occur in a way that they aren't compatible. So it's basically, we have to control whether we are getting input from a pipe or standard in so that we can avoid getting into an infinite loop. So if basically the shell input is going to be while 1, we're going to printf just some symbol so that they know they can type something in, and then we're going to read in whatever they type and send it to the interpreter function. Whereas with the pipeline, we are going to wait to receive it, we are going to execute it, and then we are going to exit. So the difference is this loop. In the shell, we want to allow the user to type in the next command, so we put them in this loop, versus in the pipeline, we are not going to wait for another command. We are going to open that pipe, we are going to take out what's in there, execute it, shut down. If another one comes in, they're going to have to tell the program to activate. So we have to control what happens here. And there is a function that already exists. And I don't know if I remember exactly what it was. Someone on the Discord server showed it to me earlier. I believe this is Camel Coder. He's been very helpful in a lot of these projects. So thank you to Camel Coder. He's been excellent. OJ002 on Discord. This function right here is, I don't know what this exactly stands for. It looks like is attribute file number standard in. So this function is going to basically tell us whether or not the function or the application is launched via a pipe or via the command line interface. It's really simple. I would like to know what the source code is so I can see exactly what's going on. I'm willing to bet it's something relatively simple. So we take standard in as our input here. This seems like it's going to return the file number. And then it would probably just check, is that file number equal to the file number of standard in or the terminal interface? And it'll probably be pretty simple to figure out, but there it is. And I don't remember which library it comes from, so yeah. So maybe Unistandard. Just some of the generics we'll see. So there it is. Okay, so if attribute file number standard in, Camel Trader is a TTY, and a TTY is another name for the terminal. TTY comes from teletypewriter. That word looked very strange from this distance. Teletypewriter. That's really interesting. So is a teletypewriter. So this is checking whether the standard input of when converted to the actual file number is a teletypewriter. That's fascinating. Thank you, Camel Trader. That's awesome. So yeah, this is going to check whether or not we are using a terminal interface or a pipeline. And if we are using a terminal interface, I believe that's what it is, we can enter our while loop. Well, first we want to create a character buffer. We'll give 256 characters. That seems reasonable. And I want to include that so I can use memset over buffer 0 256. Now, the reason for that is I often run into trouble when I use loops and I use a buffer. So I want to make sure that I empty that buffer and make sure it's completely clean before I start doing anything with it. So I have that, but actually that shouldn't be there. We are going to use a loop. I think I'm going to use a do while loop. Oh yeah, I think a do while loop is perfect. Do. How often do you get to do that? Anyway, memset. You guys actually use do while loops often? I find that I'm using them more often these days. I don't know why. At first I would rarely ever use them, but now they're coming in handy. Anyway, I don't know why. And we're going to do that 256. We're going to set that clear. We're going to print out a little symbol so that they know that they can type something in. And then we're going to get S from buffer. We're going to get 256 characters at a maximum from standard in. Camel Trader, character buffer 256 equals 0. Does also clean the buffer. That is a far better way to do it. Ooh, but it isn't actually. That is a far better way to do it right here. And since I'm using this do while loop, the thing is when I write something into that buffer, I want to use memset to empty it again. So I can declare this variable down here and set it equal to that. I suppose that would work. But, you know, I don't actually know. What is more efficient? Declaring a variable of 256 bytes again and again and again and again, or using memset? Now, one thing in the variable's favor is that it is on the stack rather than the heap. If we were allocating this on the heap, I would say using memset is almost certainly faster, but the stack is quite fast. So I'm actually not sure which one's faster. Well, I'll tell you what, if we think about what's going on in the command that Camel Trader just shared, we can think of it like this. And I don't know if this is actually what's happening, but this is my hypothesis, that we have our stack pointer and we say we want to allocate 256 bytes. We want to set that equal to 0. It's going to go through basically in a for loop and set each memory address to 0. And I think that's probably what memset does too. I don't know. I don't know the implementation for memset. I don't know. The compiler is going to do some crazy optimizations anyway. I didn't know that it did that. Anyway, we could enter a for loop here. I'm going to guess that this is roughly what memset is doing. Int I equals 0, I is less than 256, I plus plus, and then we could simply say that buffer I equals 0. And I'm guessing that's what memset does. And if creating this character buffer and setting it equal to 0 in the loop means that we move the stack pointer, set them all equal to 0, and then move the stack pointer, set them all equal to 0, and then every single time, then it's probably more efficient to declare it once and then just set them all to 0 again and again. So that's probably the most efficient thing to do. So I think that's what we'll do here instead of my special loop. I've been thinking about doing a series where I take some of these functions that I'm using all the time, memset or string length or stringcat, some of these functions, and looking at the source code for them and breaking down how they actually work. The whole reason I wanted to come to C in the first place was sort of to peel back the layers and see how things were actually working. And to find functions like memset, of course it's useful, but It's just another curtain, and I want to see what's underneath. So maybe I would do a series on that. Let me know if you're interested in that. Anyway, so we are going to print that to the screen. We are going to get that from standard in, and then we are going to call the interpreter. And here we have a problem because the interpreter wants an array of arguments, and this is going to get a string, so we can have spaces in there. So we probably want to use some string tokening to slice this apart. That's going to be an issue, but for now, let's just pretend that's not a problem. And we're just going to pass in 2 to say that our argc is going to be, we're going to have 2 arguments. The first one's going to be the name of the program. And then we can say, well, how are we going to pass this in? I suppose we could just pass buffer. So that's something I need to flag that. And let's go ahead and head over to Git so I can do this right now. So I've been playing around with this a bit, and I'm going to open up an issue. I have some projects here, and let's create a new project. A terminal interface. I don't really know which of these to use yet, so I'm just going to stick with automated Kanban. I know what Kanban is, but I've not used this automated process. It seems fancy. I liked it so far, so I don't know exactly what to do there. Let's just archive. Get him out of here. Anyway, let's create an issue. Our issue is going to be the interpreter in the shell interface. So our interpreter takes the direct command line and arguments. I'm going to flesh this out in a little bit. I'm just going to write like a sentence here and then edit it later so you don't have to watch me type. So the interpreter takes direct command line arguments, but the shell interface is going to grab an entire string. So we're going to need to separate them somehow, and we're just going to do that later. Okay, and I'm putting myself on this issue, but you are absolutely welcome to join me on GitHub and actually help out. You can submit source code, you can just leave some comments to talk about the issue with me, you can join on and do whatever you want here. So feel free to come over to GitHub and actually join me here. So this is for all of us. So this is going to be in the terminal interface project, and it's in the to-do section, and let's put in some labels. So this is going to be help wanted and a discussion and a bug. Okay. So yeah, you can join us on GitHub and go to the blockchain project, and you should be able to see this, and we can discuss this problem further and return to it after we have made a little more progress here. Okay. So we're going to pass in this, but see, even that is a little bit, even that doesn't really work. So I'm just going to comment this out for now. That's going to be a problem. And we're just going to keep doing that. So for now, let's instead we're going to print out we'll just print the buffer. We'll just return exactly what they said instead of calling this interpreter. Okay, and it'll just loop over that while string compare buffer and quit does not equal 0. And we need to say quit \n because it's going to get our return character from that. Okay, so while that is true, we are going to continue looping. So long as the user does not type in quit, then we can continue this loop where we will reset the buffer, get them to type in a new string, and then we will print out what they said to us. And I think I should... No, I don't need to do anything there. Okay. So that needs to be replaced with the interpreter at some point, but that is basically our shell interface. We just get the message from the user, and then we send that right over into the interpreter. So if it is not being activated by the user interface, then we are going to be dealing with a pipe. And so else, in this circumstance, we are going to open our pipe file. And here we are going to want to use a named pipe. So that is a bit of a trick. So how are we going to get the name of the pipe into this? We want a different named pipe for every single application, almost certainly. So we should probably create a, well, let's make it constant character pointer, and we'll call it pipeline. And this will be the path to our pipe file. And we'll probably want to create this manually on the system for the project, but we'll demonstrate that in a moment. So we are going to need a few libraries here in order to do this. We are going to need, we have Uni standard already. FCNTL is the one we are going to need. So, and we need to add our pipeline argument terminal. Okay. If that updates. That'll be fine. Yeah, it's fine. Okay, so if this is not a standard input, or a standard input is not a teletypewriter, I think that's what Camel. Yeah, teletypewriter, yeah, pretty cool. Anyway, if it is not a teletypewriter, then we're going to open this pipe and wait for something to come in, and something that we can interpret. So we are going to, how did I even do this again? Int pipe equals open, and this open file takes a path as its first argument, which is going to be pipeline, and then it is going to take an argument that says the mode in which we are opening this pipeline. And I'm going to open it in ORDWR, so read write. And the reason I want to do this is that we may want to capture the output of this in some way. So, well, that is a trick. So here's where we come to the design decision that I haven't made up my mind about yet. So when we are working with this, what I'm thinking of, in the case of Git, for example, our output is almost exclusively text. If I just say get status, it's just printing out some text. It does things behind the scenes, but the output of each of these commands is text just telling you what happened behind the scenes. Whereas in our blockchain, the output from some of the commands, so if I create a block or I read a block, the output from that command is going to be raw bytes. And so what are we going to do with those raw bytes? Well, if they're using it from a command line interface, I suppose we could just save them, and we would probably expect that the user would pipe those themselves into some arbitrary file. But the issue here is whether or not we want to separate input and output. Okay, so if I have a application that is using this terminal interface through a pipeline and they write a command to it, should the terminal use the same file to write the output, or should it have a separate file called output where it writes that? So that way all of the commands come in from one pipe, all of the output goes out from another pipe, or should they be able to communicate back and forth through the same pipe? And that unfortunately determines how we are going to implement this here. So if we are having two separate ones, then how is that going to look in this? So they're going to open the pipe for input. They're going to wait to read something from it. They're going to open the pipe for output, and then they will write the response into that one. And then the third-party application will read from that one and write to the other. And, in the demonstration that I did on my... Where is it? I'm not going to pull up my YouTube channel right here. That's too meta. In the demonstration I did of pipelines, I actually used the same file for reading and writing. I'm just worried that that might cause problems. So I can see some opportunities for race conditions in there where, like, what happens if multiple third-party applications try to activate it at the same time? Are these pipes thread safe? I don't know. It seems like reading and writing input and output to the same place is a risky thing to do. I'm going to have to think about it, so I'm going to put another note in here, and we're going to call it pipelines. Should input and output for the terminal interface be typed in the same file or separated? Okay. Label is going to be discussion and question. This is more an application design question. And no, let's put it on terminal interface. It's part of terminal interface. Okay. Camel Trader, why do you even open a pipe? Can't you just use the pipes that are created by default, as in standard in, standard out, and standard error? Yeah, so the problem that I had there is that those are one-way channels of communication. So if I open the pipe with a file pointer equals popen, and then I put in the name of whatever I want, I can write to it, but then the output of this, it can't capture the output back. The other application would need to create another pipeline for it to give the data back. So we would have to do this anyway. And since we are doing it anyway, might as well. And also, what I'm expecting in the blockchain side of this is that the third-party application is going to write their output to the input pipeline. Then they are going to use this style of opening in order to launch the terminal for the blockchain application, which will then see there should be something waiting for me in the pipeline. It will grab it and read it. So yeah, so the reason I'm opening these pipes is specifically so that this terminal application can write raw bytes back to whoever called it. Okay, so I want the third-party applications to be able to have direct access to that data. So that's why I'm opening a pipeline for reading and writing. And the question I have is whether I should do that through a single file or through two files, where an input pipe and an output pipe, or just one for both input and output. Probably safer to do two, probably more efficient to do one. I'm not sure. I'm going to think about it. This is not staying for long. Anyway. Okay, so we've opened this pipe. Now we need another buffer. So character buffer 256, and now we're going to set this one equal to 0. I'm running out of battery, so I'm probably going to have to lose the face cam, unfortunately. And I should probably take a 5-minute break here and get some water so that my voice does not give out the next 30 minutes. So, Camel Trader. Okay. I thought that popen works in both directions, but you were right, and that isn't the case. Yeah, see, I was trying to get that working throughout much of the week. There are a number of examples in the sketchbook that didn't quite work so well. And yeah, it's a bit finicky, and that's why I'm worried about using a single file for this. It seems like I have a feeling this is going to cause some problems, and we'll have to change that. But let me take 5 minutes here and just grab some water, and I will plug in the Mac, and we will be right back. We will finish implementing this terminal interface, and then we'll start trying to do some more particular things for blockchain. So I'll be right back, and thank you for joining me. Okay. Welcome back. We seem to have lost all but one. That's okay. Cool. All right. Where were we? Okay, so we've opened the second pipeline for reading and writing, and first we are going to read from it in our character buffer. We need a semicolon. That is probably that one person who stuck around while I was AFK, probably frustrated by that error message by now. Anyway, so we're going to read from the, not buffer, but from the pipe. We're going to read it into buffer, a maximum of 256 bytes. Okay, and once we do that, we are going to pass that off to the interpreter. So now we can call the interpreter, which will have the same problem. So for now, we're just going to printf sent s buffer. We're only going to do that once. And we are going to set Well, okay. What we would usually do is set int result equal to the buffer, or the result of the interpreter. Or not int result, but result equal. We've already declared it. So we would set result equal to that, but instead we are going to leave it alone for now. Since it's already set to 0 up here, when we finish this, we can just see that it'll still be 0 and it should be fine. Within the interpreter, we might actually consider passing in the address of this so that we can switch it back. And in fact, we might want to do that in the main application as well. But I mean, this is equally fine. So this is wrong as well. I need to that instead. So what I had here was a function that returned an int pointer, and instead I need a pointer to a function that returns an integer. So that's what that change does. Sorry about that typo. Anyway. All right, so we have these two cases. So the only other option, so either they have put no arguments, in which case something has gone horribly wrong because how are they running the application in the first place? Or they have one argument, which is just the name of the application, in which case we need to wait for new commands. So we will either, depending on whether they're using the terminal interface or they are using a pipeline, we will get that information from the user input or from this pipe, and we'll print f there. But instead of printing here, we need to work with pipes. So we are going to write to pipe buffer string length of +1 for that null terminal. And then we will close the pipe. So this is a one-shot thing. When you open this through a pipe, it's just a one-off. And you would open this in the, as I said earlier, using that file pointer method and popen. And the idea there is that by launching this through popen, it would see that there are no arguments, and it would just read from this pipe, which presumably you have written to in your third-party application. Okay, so that handles the case where the user has one input, and the last is the default case, and this is the easiest one. We're going to, instead, we're just going to set result equals interpreter. We're going to pass it argc and argv. Just going to kick the can down the road and let that handle the rest. Now, when we actually implement this, we would define what our interpreter is, and that's where we would give all of the different things for our commands. Now, one thing I'm seeing right off the bat that we put into an issue over here. Oh, I didn't finish this? Okay. Anyway, we put it as an issue. So we may consider putting in the string tokenizer, the thing that's going to split these buffers on spaces, in the .c file. So put a So if we define this function in here, oh, all of this should be in livom instead. Oh well. If we define the function here that returns a character pointer, and we call it tokenize command, and it's going to take no, it's not going to take argc. It's just going to take a character pointer called command. I don't know if I actually want to do this part of it right now. Character pointer. I would have to use malloc for this, wouldn't I? Unless yeah, let's do this tokenizer another time. I want to parse strings right now. That's not the goal for today. So I put it in as an issue. In the future, we can create a tokenizer that is going to split this string on its spaces so that we can actually send the appropriate arguments to the interpreter. And that's what we will do here probably to solve this problem. We'll just embed the thing that handles that up here. And there's additional things we have to worry about with quotes. So, yeah, that's going to be annoying. Anyway, we'll leave it for now. Okay, so that's our generic terminal interface. And now let's go ahead and implement it into the blockchain project so we can see how it works. What was that? Test.py, I remember that. Okay, so here is our main program. You can see I've already defined a interpreter object, and int main is just going to call this terminal function passing in argc, argv, and the interpreter. And then I define the interpreter. Actually, it's just going to print the message. So this is actually pretty simple. And one thing I want to point out, so with libeom, there was some discussion, I believe, in Discord a couple of days ago about the global paths that people search for. So let's talk about that really quick. Here you can see I'm using the greater than and less than sign in order to wrap this include statement. And that's because that is actually located in one of my global search paths, user/local. And here I have include, and I've put my own library right here. Now, typically speaking, you don't really want to just arbitrarily throw files into this include. This is your global search path. This is kind of for final products, things that have been released, that are done. And when you're prototyping and just experimenting, largely like what I'm doing with libeom, it's better to use a relative path because you're just not installing it on your system in this way. And it just kind of keeps things cleaner and helps you follow the organization that your machine is expecting. Now, why did I do this here? Well, when I started this blockchain project, I realized that it was time for the project to sort of split from libeom. And at that point, it made sense to create a stable release of libeom. So in here, I have the latest stable release from main. If you download the main repository, or the main branch from my libeom repository, this is exactly the version that you are going to get. And that's what I have here. This is my quote-unquote installation of libeom. And here are all the new features of libeom. I'm adding them manually. And what will happen is once I bring these elements into a stable release of libeom, I can simply remove these include statements and it will all still work. The reason I'm doing this is I kind of want to make it, I don't know if this actually made it clear now that I had to explain all that, but I want to make it clear how libeom works, and I want to demonstrate why you would use different kinds of paths. So that's just a quick example. And what are these? Anyway, experiments I was doing. Okay. So that handles most of what we need for this blockchain thing. So if how am I going to... Okay. I'm going to compile this from the command line. And I need to gcc blockchain / main.c. I need these. Block.c. Will that work? And I need one more thing. It's terminal.c that I need. I don't know if that command is actually going to work. Hey, it worked. Okay, didn't like it. So let's just run Well, the shell interface seems to be working. Shell interface works great. But taking in the arguments. It does not like taking in an argument. So let's take a look at what went wrong with that. I think argv. Definitely here that we're having the problem. And what is my interpreter doing? Oh. It takes the wrong arguments. What you get for not checking your code, Eric. This is going to take int arg c. Let's be consistent. V. Okay. And this needs to be an int. Yeah, I made this prototype a little while ago, and really things have developed since then. Okay, sorry. And we need to print argv arg c minus 1. We'll just print out the last command that they put in for simplicity, or actually for int I equals 0, I is less than arg c I plus plus. Let's just print out all of the things that they send us. Printf send s argv I, and then turn 1. Or not 1. And Camel Trader a while ago said it was standard or exit success. I'm going to stick with saying 0 for now. I had exit failure earlier, and throughout a lot of this, well, there's not a whole lot of returns. I don't know. Maybe I'll switch to that, but I would want to do it throughout the whole library, so I'm going to worry about that another time. Okay. Feel free to open an issue in the GitHub repository if you feel strongly about that. Anyway, so we are going to print out everything they say to us, and that should work. Not sure why it's... I think that's just not updated yet. So let's redo that. Oh, yeah. Nope. To parameter of type void pointer constant character. What does it not like? Oh, I see. I am missing something. I turn in that, and I'm going to pass in a pipe name. And what pipe name should I use? Well, in this circumstance... Oh, I guess... pipe. I see. Here's something we can do. We need to actually create this pipe. Expected 3, have 4. How could that possibly be? 1, 2, 3, 4. I think something is askew here. That's not updated. What's going on here? This says 4 arguments. Importing. Does that mean I have a... Here was an earlier experiment. Get that out of here. Okay. Does that mean my... There we go. Okay. Shell interface is working. Looking good. Uh-oh. Oh. I think that looks perfect. So our terminal interface seems to be working. The only thing we need to do is test opening it with a pipe. So I'm going to go to my desktop, and I'm going to touch s.c and int. Yeah, int. Ooh. Wait a minute, which one of these am I opening through the pipe? Oh, okay, yeah, I see. Okay, int main. We're not going to take any arguments. We're going to be a little bit lazy with this tester. And I'm also not going to write it in nano. let's be sane, shall we? Okay, so we have our main function, and here we are going to create a file pointer. We need a few libraries. Do I need another library? I don't know. Let's see. Okay. So our file pointer pipe equals p open. And I'm gonna put the full path in. user/eric/document/blockchain/out. And we're going to open this in write mode. And then we are going to say fwrite pipe. And I'm not getting my things to fill it in, so I don't remember what that actually has in it. So let's see. Nope, not giving it to me there. Killing me. There we go. Cheating. Okay. So which one is which? Okay, we're not actually going to write anything to this. We're just going to put that. We'll put 1 byte, 1 item. For some reason, that doesn't feel right to me. We will see. But that's not all I have to do here. So this opens up the command to actually activate the blockchain program that we wrote. But we first need to actually write to the pipe that it is expecting data to be coming in on. So that is whatever we have passed in as the argument somewhere. Here. Okay. So we need to make one. So let's go to cd. Okay. And what we're going to need is a pipe file. And we can create this with mkfifo, or make first in, first out. So a pipe is a first in, first out data structure. Whatever you put in first is the first thing that will be read out, and it gets removed as soon as you do. So we can make a first in, first out pipe. and we're going to call it pipe, but the question is, where does it go? Where in this project should it go? Probably under products. We have a folder in this that's actually called products, or is that some pointer? We don't actually have a products folder. Where is this products folder? Users, Eric, documents, blockchain. I see no products. Okay. Oh, look at this. Yeah, this is just a pointer to it. So I'm just going to create it kind of at the top layer here. We'll worry about where this goes later. So I'm going to make this pipe, and if I do ls-l, we can see that it exists right here. And now we can open it. So in this, we are going to int fd for file descriptor equals open. Here we're going to need unistandard.h and fcntl.h. Okay, so now we are going to open that pipe file /users/Eric docu /pipe. We're going to open it in O. Right. And then we are going to create a character pointer hello equals hello world. And we can write this to the file. So we are going to write to file descriptor hello. And then we'll include string.h. Now, why don't I just put in 256 here or some buffer number? And the reason is that when I'm reading and writing, it's best to use the exact size, because oftentimes these are I've run into problems where I end up in infinite loops where I'm trying to write something to the file, but I think what's going on is that it's trying to write 256 bytes, but it only has 5. And until it gets the other 251, it's not going to finish. So I'm trying to be more precise with how big I say these things are. So we can write that to there, and then we can pretty much close it. We don't need it anymore. And that should do it. That should do it. So here we are writing the command into the pipe file. And if you remember, the actual terminal application is what is going to read from that file. And what we have to do is actually pass in the name of our pipe when we create it. And this is going to give us a relative path. And we might need to use a full path. We'll see. So this should work. So we write to the pipe, and then we activate the terminal, which should read from the pipe. And that should do it. It's going to call the interpreter, which should just print out arguments. So it should just print hello world. This is a very, very bad hello world function. And we're going to go to uh-oh. Typos. Okay. I believe that worked. I believe that worked. Did it? Okay, so it printed out this, the argument. It should have printed out hello world. Why did it not? Let me take a look. Okay. We got here. buffer. It looks like I need to read it back from the pipe. Let me see. I'm going to use ls-l, and this is going to tell me the size of everything. And pipe is currently at size 0, so it does not seem like anything was written to it. Let's go ahead and test a few things. So I'm going to put in a few print statements. I'm going to need to recompile the original. Okay, so it printed 1 and then it printed 2. That's kind of strange. So it's getting into this terminal. And it should be right here. And the good news is that we're not entering some infinite loop. So we know it's actually getting to here. And what's going on? It creates a buffer, opens the pipe, reads from the pipe, doesn't call the interpreter. Writes, closes, exits, terminal. It's peculiar that it's actually printing anything out at all. I wonder if I just tell it to, instead of this. Oh, which one am I editing here? This is the blockchain one. Okay. I'm getting turned around in my own project. Okay. Now we'll just compile this. Very strange. Okay. So, this application, we open users Eric documents. Ah, that's it. It's in the wrong place. Of course. Documents blockchain / pipe. Silly me. I do. Is there going to be a pipe in there? No. Fortunately, there's no pipe in there. Blockchain.key. That is. Okay. Okay, so we fixed that over here in the main file, so we have the correct path to our pipe. Remember, this is a named pipe, so I already created it on the system, so I have to give the correct path to it. Otherwise, it's not going to know what I need to open. So let's try and compile this one more time. Still nothing. Still nothing. Users, Eric, documents, blockchain, pipe. Exists. And I also don't know where this is coming from. Where is it printing that? Is it here? Why is it doing that, though? Why is it calling the interpreter? It shouldn't. Unless. Yes. Okay. Okay. Yep. Do you remember what I was saying earlier about switch statements? Okay, so your switch statement, you have to say break after the case. Otherwise, it'll execute all of the subsequent cases. If we look here at case 1, I did not say break. So afterwards, it executes the default case. And the default case calls the interpreter, which is going to print everything. So instead, I need to say break. And that fix it. Long one. No. Uh-oh. Oh, I need to change my working directory. Okay, we got that, and we can now... Ah, we are so close. What happened? It didn't write it to the screen. Okay, it stopped printing out the thing, so we know that that part worked. This putting in the break statement, that definitely worked, but we didn't get the buffer. So, I'm willing to bet that the problem lies over here. When we pass in this, let's give the absolute path. Users, Eric, document / block pipe. I bet you that is the problem. Because it's when you put in a relative path, the question is, it is relative to what? And it's relative to where you're executing it from. I'm executing from my desktop, so every relative path is on my desktop. So there is probably a pipe on my desktop now. There isn't, and the reason is I did not pass in another argument. So I'll just demonstrate this very quickly for you. But you can put in an argument in your pipes. I'm sorry, I know I'm whipping around between screens. Here we go. We can put in create, and it will create the pipe if it doesn't exist. But I am assuming the pipe already exists. Hello, Elon Max. Any relation? That's funny. Anyway, so we can tell it to create the file, but I'm just not going to because I've already manually done that. Okay? And the relative path in this circumstance is the desktop. So when I tell it to open something that is just called pipe, it's going to open it on my desktop. But I didn't tell it to create it, so there wasn't anything there to find. Let's try this one more time. Where did I put that, though? This one on my desktop. Okay. Ah, still nothing. Okay. Its size is 0. So interesting. Users Eric documents blockchain pipe. Okay. And that looks good. Pipe, rewrite, we're going to write to it. Maybe we should do that later. Maybe we should close it after. I bet you that's going to do it. That was, sorry, where was it? That was main. Okay, that's easy. Ah, nothing. Killing me. Let me check out my own work here. That's why it's here. That is why it is here. Let's take a look at the sketchbook and the pipes. Sketch. From, what does it do? Open that right. Right. Yeah. Process. Write mode. And then P close the process. Ah. Maybe that'll do it. And I think as soon as I find something that might be a solution, I just jump in and test it, which is exciting, but as you can see, doesn't always work. Just test it immediately. We're going to open that in write mode. That open statement's a little bit different, but I don't think that's necessary. Close it. We read from that pipe. But it shouldn't need to. We shouldn't need to do this part. Because the interpreter is not being called. Open the pipe. Read from the pipe. We print it. We close the pipe. Maybe there's a problem when we write to the pipe. So we open the pipe, we create a string, and then we put that string in the pipe. That looks correct. Okay, let's try pipe 2. What do we do over here? Open, pipe, read, write. So far, so good. We read it into the buffer, and we read the pipe into the buffer. We print out the buffer. What's going on? You guys see any problems that I'm not seeing? Let me know in the chat. But so far, I'd like to design a way to test if this is actually writing to the file in the first place. So I'm going to do something kind of silly here. Comment all of that out. And what's going to happen is that this, since we never close this, it's never going to finish running this. And what I'm noticing is that if I do ls-l on the pipe, we can see that it has a size of 0. And that's fine since nothing is currently using it, but what I want to do here is kind of get this trapped in an infinite loop where it's written to the pipe, but it never closes the pipe, so it never finishes executing. And then while it's doing that, after it is written, I want to see the size of the pipe and see if it has changed. So if we come over here and input test dots. So if I a.out, it should enter an infinite loop. It didn't. Okay, so let's make it. Okay. Okay, now if I hit Control Z, that sends that to the background. It's still open, and if I hit, it should be one of the top things in an infinite loop. Will be S. Oh, well, I'm running a bunch of other things at the moment. Not quite sure. Anyway. How do I get back? Control C. There we go. Okay, so now if I ls-l on blockchain/pipe, its size is still 0. What if I pipe that into the let's see. I think this might be a permissions problem. So let's try checking out the permissions on that. So if I do ls-l again, we can see that, no, not that one, this one. It only has read-write access for the owner. So let's do chmod 0777. That's going to open it up completely so that the owner, the group, and guests have read, write, and execute permissions on that pipe. And we'll do that to pipe. And now let's go back to the desktop and execute a.out. Oh, it's an infinite loop. I'm sorry. .out running, infinite loop here. No. Good. Let's undo some of this here. Ah, still nothing. What is going on? I really don't know why this isn't reading from our pipe. Read pipe into the buffer, 256 characters. Pipe into the buffer, 256. It's... I wonder if that has anything to do with it. Passing it in as an argument. I'll need to pass it in as an argument eventually. There's not really a way around it, but... did I actually find that? Yeah. This is Eric documents. Blockchain pipe. I'm sorry, guys. I don't know. This is this is like exactly the same code that I did before. You know, it's probably something silly, to be honest. It's probably some minor thing that I'm overlooking that as soon as I turn off the camera, I will see and feel quite embarrassed about. But I am not seeing it right now, and that's what counts. So let's just see. What did I... Sorry. Oh, I forgot that you guys aren't seeing my face right now, and I got a notification, so... Anyway. Okay. Where do we want to be? We want to be in the blockchain folder for that command. Which one are we trying to compile? libom. Nope, no. I'm sorry, I'm kind of scattered here. So, getting rough, guys. Sorry. So what I'm doing is I'm trying to recompile this one file of libeom. So here's why I'm a bit scattered about this. Libeom, as I mentioned earlier, exists as a main installation in my global search paths, but this particular version of it is a working branch. So these two files are not included in my global version. So in addition to linking the global version, I need to actually compile these two files. These two files are in libeom, but they're being used in the blockchain project. So I need to go to the blockchain directory in order to run the command that will compile these files with these two files linking to the actual installation of libeom on my machine, and that's why I am a bit frazzled. at the moment because I had to just work that out in my mind on a live stream. So forgive me for that. We're in the blockchain folder. We can go up and find our GCC command. I'm being a bit lazy not typing it out again, but typos. Okay, that should be good. Hello world. Okay, that was the problem. We found the problem. So, in passing in this argument here, this pipeline, we had an issue. Okay? And where that issue was, I am not sure. Unless I spelled it wrong over here. So let me try. Let's try this. If I paste it, we should see no change. I did not see a change. Nope. Okay, so passing... Oh, wait, that's the wrong spot. Whoops. Here is the right spot. Right spot's over here. Over here. Okay. So if we see a change... No, okay. So passing in this argument did not work. And I'm guessing it has to do with the scope of where these things exist. No, that doesn't make sense because this is compiled together with the components of libeom. So when you have a static library, if we look at the actual library file for libeom, go to folder, go. Not in there, it's in lib. Yes, here it is, libeom.a. This is a static library file, and this is sort of halfway between uncompiled and compiled. These are pre-compiled binaries that are all the code of libeom, but they're not executable. There's no entry point. There's no main method. And what we can do is when we create a file with a main method, we can compile this with all of these pre-compiled binaries, thus combining them all together into one file. The static library just makes this a little bit easier to do, so we don't need to list every little component in the library in the compile statement for this. We just link the two. Now, why was I even telling you that? Okay, so the point is that when I compile in my blockchain project and I do this terminal and I pass in a string literal, what I was thinking is that this blockchain project is a separate project from libeom. So it could be that since they are separate things, that you can't actually pass in a thing like this, a string literal in this way. But since they are actually compiled together into a single executable file, you can do this. There is no problems with those memory addresses. So there seems to be a problem with setting that path, and I wonder what that issue is. So if I create this and just don't use a string literal, and then over here we open pipeline, the character pointer. Okay, now all the compiling again. So, go. I think that may have done it. Okay, so passing in a string literal to this function here caused a problem. It would try and open this pipeline, but that didn't work. So over here in my actual blockchain application, I just defined it as a variable, and then pass it by variable name. And that worked successfully. So we have our pipe set up. Let's just put a little final touch on it that we can read back what they said. And instead, we'll print out what was sent to the terminal. We'll write something back, and we're not going to write buffer. Hello yourself. And then over here, we can now create a new buffer equals 0. And then we can read from fd into buffer 256 printf sent s \n. That do it. Have all the commands right here. So 1 2 3 4 5 4 5 1 2 3 4 5. Hello world, hello yourself. We have two-way communication between these things. So what have we accomplished in the blockchain today? Well, we have created in libeom a generic terminal interface, and this terminal will, well, first make sure that things are actually working as they should. This should never happen. Case one is if they are not giving any arguments, and either they want a shell interface when they're using the interactive terminal, or is a teletypewriter, as Camel Trader told me. So if they're using a teletypewriter, then we are going to open up this infinite loop, more or less, until they say quit. That will basically allow them to type in one command after the other. We're going to need to do some work in order to pass this to the interpreter. We're going to need to tokenize this string by splitting it on spaces, but we can deal with that. And we're going to just do that until we're done. And let's see. If they are not, then we are using a data pipeline. So if they are not using a shell interface, it's a data pipeline. So we're going to open the named pipe that we have already created for this project, and it will ship. That pipe will ship as part of this project. Creating that pipe will be a part of installation. And we are going to read from that pipe. Once we get it, we'll print what was read, we will respond to it, we will write to the exact same spot, thus demonstrating that it can be input and output in that one file, and then we close the pipe. So here we can execute as many commands as we want. This is a one-shot deal. And then the only other possibility is that they have multiple arguments, in which case we can just pass those directly to the interpreter in the simplest possible way. And that is basically our complete user interface here. So what's really nice about this is that it's portable. So this terminal function we can put in any program, and we just need to define our interpreter so that it has the tree-like structure of all the possible routes that we could take. And it checks for errors, and it is going to allow for a data pipeline or a shell interface. And I'm pretty pleased with this so far. Now, we do need to do some work. It's not going to just respond with this, and I'm not sure about this. What should it do after? Maybe it just hits the interpreter and returns whatever it got. Or, I'm not sure. We'll see. Or writes whatever the output is to that pipe. We'll have to see. We'll have to see. But I think this will do for this part right now. And I think what we'll do is talk about what the next step in the blockchain is. So we have the rudimentary elements of our user interface, and now we need to write out what that interface is going to do and basically give our commands. So I am looking at 42% battery, so I'm going to turn on the face cam. And I think we should be good. Let me check OBS, see that my lovely face is appearing. Ah, there I am. Okay, so let's talk about what the modules of this app, of this blockchain, are going to be. I'm going to get rid of this for now. Now, I prepared a lovely PowerPoint presentation for you, and it looks different on my screen than I think it's looking in your view, so this, fair warning, may be a bit strange. So let's see. Oh, that looks pretty good, I guess. I can't tell. Oh boy, what's going on here? Oh, that did not work like I thought it would. I can kind of see it in retrospect though, so let's... Is this in... Oh, that's OBS. Okay. Sorry, this is probably this is probably pretty weird. I did it again. See, I have a second monitor that's showing me what is on what you guys are seeing, and it's thinking that I want to like show this as a slideshow on that monitor. So I really have no idea what's going on. And now I can't even find my mouse head. Okay, that's unfortunate. I put some work into that, not a whole lot. We'll deal with it. So let's just take a look at this. If we have, we'll basically can think of having 4 modules in our blockchain. We're going to have an author, a publisher, a librarian, and a reader. Author is going to be responsible for creating blocks. So our command might be something like this. Let me rearrange these so I can work a little cleaner. Our command might be something like this: blockchain author, and then I can put in /user/eric/example.html. And I can basically take the bytes of this file and turn it into a block file on the blockchain. And the author module just does that. It is just going to create a block out of some data you give it. We could also give it raw text. So maybe we say, hello world, and it will turn that into a block. Okay, all this does is create blocks. And the output of it is the bytes of that block. And those bytes should be sent to the next module in the line, the publisher. This is what's going to share the blocks. So it'll have a list of other people on the network. And when you want to share a block, it can either share it with someone in particular, a few people in particular, or everybody. And so your publisher, you would access that by saying blockchain publish, and then you'll put in maybe the hexadecimal code for your block, so it's hash, and then that thing will send it out to whoever you want. And let's just pretend this is a actual hash, and maybe I would say -2, and then I put in an IP address, and these would be specific people that I send it to. So I can put in additional commands. But basically the idea is we would have a publisher module that would be responsible only for sharing blocks on the chain. And then we would have a librarian module, and this would be basically the kind of database component. This would query the blockchain. So you would be able to search for certain blocks based on some of the headers. We look at the blockchain project I have here, we can see in my block.h, I've already defined what some of these headers are, and I'm not convinced that these are exactly the headers I want yet, but basically our librarian would allow us to query all of the blocks on the chain, either locally on our machine or stored on other machines on the network by asking their librarian for things. Basically, we'd be able to query based on these fields. And that's the librarian's job. It's just going to return maybe the hashes of all of the blocks that work or that fit your query. And then last we have the reader. And I'm not even convinced that this is something that we are going to implement on our end. This is sort of the third-party application that is utilizing these features. So maybe I write a third-party application that is going to be, I don't know, just a website, and I'm tracking users on the website. So your user information is stored on this blockchain. So when you, as the person, let's say you've downloaded an app that is using this blockchain, then when you create your account, essentially that application, this third-party application, is going to use this data pipeline as an API to the author, and it will take whatever your input is for user information and create a block out of it. And then if you want to share that block with the network, then you would send those raw bytes to the publisher. The publisher will deal with who is getting those blocks. And then later on, if someone wants to see that block or access that block, then they would ask the librarian to get it for them. The librarian would return the raw bytes, and then the reader determines how that is displayed. And that's why I'm saying that I'm not convinced that this is something that we are going to implement ourselves, because these are raw bytes that we're sending back and forth. Perhaps I am running a service where I send HTML files in blocks, or I have HTML files in blocks, and maybe you are running a service where you have MOV files in blocks. Now, the program I would use to open the MOV file and the HTML file are totally different. So that is your reader. So you will set the third-party application up in such a way that the author knows how to create blocks, or you author your blocks such that they have a predictable format in the data. Then your publisher can send it in certain places where you know where to find it again. And then you'll use the librarian to get it again. And then once you have retrieved it again, your reader will know how to interpret the data that is stored inside. So this is part of the third-party application. And what's important to note is that you can enter this process at any point. So if I am the third-party application, then I want to create let's say my user makes a new post, then I'm entering right here at the very beginning. We are authoring, then we are publishing, and then we are storing, and maybe reading, depending on the application. Or maybe there's already a post and I just want to share it. Well, then I would be entering here where no new blocks are being created, but I am sharing this with people on my network. Maybe I am not trying to create a block or share a block, but I'm trying to get one for myself. Well, here is my entry point. I would just go straight to the librarian and ask for it, like querying a database. Or maybe I already have it and I just want to display it, and that's where this application goes. So we have this sort of flow of information through the blockchain. And these are the next steps in our project. We are going to create these different modules. This is going to involve actual mining. This is going to involve some networking. This one's going to be tricky. The librarian is going to be the trickiest part. This is basically the web server. So this is the part that's kind of open to the network, where I, as the local user, can ask it to find me a block on my local machine, or I could ask it to find me a block on the entire network. And the way that would work is that it would send messages to the other librarians on the network, sending basically the same query message to all of them. And they would all query their own local storage, and if they find it, they will send it back to this librarian, who will know what to do with it, likely pass it on to the reader. So this is going to be the most complicated aspect of this. The author is going to be relatively simple. Publisher is relatively simple. We've actually already done things quite similar. I think we need some more robust implementations, but we can do that. And yeah, librarian is going to be tough. But once we get all these three together, then things become a lot more interesting, because we can start working on reader applications. So once we have those three core elements, we can start actually putting it to use in an actual kind of product. So that is what is to come here. So if you're interested in keeping up with the project, I would definitely recommend, if you're not already, subscribe to the YouTube channel and like the video and all of that, and keep up with me there. But I would also recommend joining our Discord server and following me on GitHub, because I am trying to up my game on GitHub quite a bit, sharing a lot there, and I'm trying to make it as interactive as possible. So if you come on here, feel free to look at some of the open issues and even just leave a comment just saying what you think, or maybe you saw an article that had something to do with something like this. Feel free to share. This is supposed to be an interactive platform. And I'm also happy to accept code. So if you have a suggestion of how to fix something actually in the code, please do let me know. Okay? So unless you guys have any other questions for me today, I think we are going to wrap it up. And next time we are going to begin working on those 3 components of the blockchain, and maybe we'll start working on the interpreter to go with them for our command line interface. So I hope you enjoyed this video, and I hope you learned something while you were doing it. I really appreciate you joining me here, and I will see you next week. Toodaloo.